All right, let's do another one of these masses for the Winch Lab. Remember, I'm getting all of my information, and you guys are going to get all of your information from this page right here. I already did the 5 pound, and you guys, with you right now, I'm going to do this third one right here for 10 pounds. So I'm going to be using this information right here to lift this 10 pounds. It took 6 seconds. The voltage was 7.5 and the current was 0.31. You guys are going to do the data and do the calculations for the 15, 20, 25, 30, all the way up to 100 pounds, including the 0, which is the one at the top. The 0 is going to give you an answer of 0 because your multiplication by 0 is going to give you a 0 answer for that. But you're going to use all this other information here on the bottom. These other rows that I already have circled, all this information to do your calculations. For the 10 pound mass, we've got this information right here. It took 6 seconds. It was 7.5 volts, and the current was 0.31. So I'm going to use those numbers in doing the calculations. And again, you guys are going to use all the other numbers there to do the calculations for all the remaining ones. So let's convert, first of all, 10 pounds to newtons. In order to do that, we use our conversion factor, which is 2.2 pounds for every 1 kilogram. We'll cancel out pounds, and we get 10 times 1 is 10 divided by 2.2 gives us 10 divided by 2.2 is 4.545. So you're just plugging these numbers into decimals, and that's kilograms. And then we're going to convert that to newtons. So 4.545 kilograms. And our conversion is for this that there are 9.8 newtons for every 1 kilogram. And that will cancel kilograms. And we get 4.545 times 9.8. It's just multiplication. Will give us 44.54 newtons. Newtons. And that goes here. 44.54. And that also goes right here. 44.54. This conversion right here that we did for the 5 pound mass, how the distance is the same distance you're going to use for every one of them. 5 centimeters is 0.05 meters. We already did this information here, just basically recording the numbers off of the data table. So the numbers we get off the data table here for the 10 pound mass, we have 10 pounds. We just converted that to newtons, and we found out that it was 44.54 newtons. The voltage taken off of that data table was 7.5. The current, again, taken off of that data table is 3.1. No, not 3.1, 0.31. Correct that, 0.31. And then the time for this was 6 seconds. So let's just go back and verify those numbers. Getting the numbers right off of here. 0.31, 7.5, 6 seconds. Very good. I got the right numbers. Now we can use the force and the distance to calculate the amount of work that was done when lifting 10 pounds with the winch. Again, here's our formula. Work equals force times distance. We just calculated the force. Again, right here is our force, 44.54. So we are going to go 44.54 newtons times our distance. And again, you guys will use this distance for every one of the calculations that you do. 0.05 meters. 44.54 times 0.05 meters gives us 2.23 newtons times meters gives us another unit we call joules. Okay, and that is work, the unit of work. Okay, so 2.23, let's go ahead and put that number right into our data table. The amount of work is 2.23. And let's now calculate the power out. This is mechanical power that was done by the winch. Okay, and we just did this 2.23. We just calculated that up above here. 2.23. Bring that down right here, the amount of joules divided by the amount of time. And again, this is taken right off that data table, 6 seconds. So you're going to be looking up those numbers on the data table every time to make sure you get the right amount of time, because that time is going to change with every one of the weights. And we get this is 0.372 watts. That's our power out of the winch. The power in that was put in by our excuse me, power supply is current times voltage. And again, taken right off of that data table, 0.31 times 7.5. Excuse me.